Hi, 102 students. Got another question here. And so as I'm going through my email, got a number of questions on different problems here. So let's look at 11. If you're watching all of these, I hope you're kind of getting the overall gist of it, that it all boils down to the universal law of gravity. So this is our universal law of gravity, and I bet this one has it in here. Let me read it here. It says that we have a 320 kilogram satellite that experiences a gravitational force of 800 newtons. What is the radius of the satellite's orbit? Now, this is interesting. They don't necessarily say this is orbiting around the Earth, but I think that is hopefully implied in here. Because I'm kind of racking my brain. I think you have to, yeah, I mean, you got to say what planet this is. All right. So I'm going to go with the idea that this is a satellite orbiting Earth. And so, which, most of them are. But NASA sends out a few to orbit, Venus and Mars and Jupiter. And so sometimes they just do flybys. But a lot of times, it's nice just to put it in an orbit and let it just sit over, especially Venus, and just sit up there and take pictures constantly. All right, so I'm going to go with the idea that this has to do with Earth. And so let's fill in what they told me. They told me the force is 800, okay? Now, G, and this is the beauty of this chapter, this is the gravitational constant. It's the universal gravitational constant. So it doesn't matter what I'm working with, the G is going to be the same. And this will give me a chance to put in the units and just remind you, G is in units involving distances in meters and mass in kilograms. So let's make sure we put all of our distances in meters and all of our masses in kilograms. Because then we would put in the mass of the two objects. So assuming it is orbiting the Earth at 5.98 times 10 to the 24 kilograms. That's right there in the book, and you can Google it also. Whoops. And so that's the mass of the Earth. Now, the mass of the satellite was also given. What did they say? I need to come back here. 320 kilograms. Okay. And so there's the missing piece. We got, an equation with one equation with one unknown. And just a couple steps of algebra here is going to allow me to solve for the radius. So I'll just multiply these three together, divide then by the 800. That would move the r squared over. So let me just figure out what r squared is. Okay, so 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24 times 320. Then if I divide that by 800, I get 1.60 times 10 to the 14. And if you can probably see, the kilograms would cancel off and the newtons would cancel off. And so this is meters squared, which is perfect because now when I take the square root, I get not only the square root of the number, but also the unit. So 1.26 times 10 to the 1, 2, 3, 4, 5, 6, 7. Oh, that makes sense because it would be 14 cut in half. Okay, meters. And that's the radius of this thing. So if I were to draw a picture, and the satellite is up here somewhere, this is this whole radius. It would be from the center of the Earth to the satellite. That's what that means. And so I've answered the first part of it. What is the radius of the satellite's orbit? But then it says what's its altitude. So its altitude is, how high is it above the surface of the Earth? So that means I would need to subtract off the radius of the Earth. So let me go minus that 6.37 million meters that we've used in a couple of other problems to get, and I'll just call this h. Put another way, I'm saying its altitude plus the radius of the Earth is the radius of the orbit. So taking this radius of the orbit and subtracting, so minus the radius of the Earth, 6.37 million meters. I get a distance of 6.26. And I believe that's going to be a million. 1, 2, 3, 4, 5, 6. Yeah, a million meters. Yeah. Good. And I think that was it. Yep. What is its altitude? All right. Take care.